Ethernet virtual circuit is sufficient for have connectivity between different sites. This is the ELAN. And about the IP addressing only, we need one range, okay? But also, I will talk about the routing process in the next section, but for now, let me to say that maybe in the market, you hear another names for the ELAN and also E-line. Look at here, you know that in service providers, for creating this type of services, maybe we are experiencing different technology. I'm not going to talk about the technologies, but one of the technology that we are experiencing in the service provider is the MPLS, and you will learn about the MPLS more than this in the next video and also in the special MPLS courses. When you are using the MPLS in the service provider for establishing or for example, giving the service of the E-line and also E-LAN to the service to the customers, maybe you hear these terms. Instead of E-line or beside of E-line, maybe you see this term VPWS. VPWS means virtual, okay, private wire service. As you can see here, we have one virtual private wire. And also for E-LAN, maybe you hear the term VPLS, means virtual private, okay, virtual private LAN service. This means that we are giving the private switch to each customer because the switch of each customer is private to that customers, not to other customers, okay? Because of that, when the underlying technology for providing the E-line is the MPLS, maybe you hear VPLS or, for example, virtual private wire service, VPWS virtual private wire service and VPLS virtual private LAN service. And also another term is Ethernet over MPLS because we are providing the Ethernet over MPLS, EO-MPLS. The names are not so important. The concept is important, but we should know, we should be familiar with the different terminology that we have. For example, maybe somebody asks you, what is the VPWS? You know about the E-line, but you don't know about the VPWS. You can say VPWS is E-line. When E-line is providing by the MPLS, the name of this service is VPWS. What is the VPLS? VPLS is E-LAN. When we are providing E-LAN over MPLS, this is the VPWS. What is the Ethernet over MPLS? When we are providing the services of the E-line or E-LAN over the MPLS, the name is Ethernet over MPLS. That's it, EO-MPLS. Okay, these terms and maybe, for example, some other terms such as the EVC and some others are creating but by the MEF. MEF is the, for example, organization or is the institute that working on the, for example, the features about the Metro Ethernet, and as you can see, this is the abbreviation of the Metro Ethernet from. Okay. Very good. Until now, we have learned about the point-to-point LAN or point-to-point Ethernet WAN services and also multi-point WAN services, E-line and E-LAN. What is the E3? Let me to explain the E3. E3 also has some functions. In some cases, for example, we want to have connectivity between the branches and the main office or headquarters, but not between the for example, the customers, the branches with each other. Assume that here we have a scenario. In this scenario, I expect to have a connectivity between the R1 as the headquarter to R2 to R3 and R4, but not between R2 and R3 and R4. Okay, this is possible with the partial mesh or point to multipoint. Look at here. You can establish one or you can buy one E3 service. How? In E3 service, actually, you have one, for example, EVC or Ethernet virtual circuit between the headquarter, this is the headquarter, okay, or the main office, another name of headquarter, and each site. For example, this site, okay, this is point to multipoint, as you can see here, and also to the site 2. Okay, and finally to the site 4. Actually, with this type of connectivity, okay, we don't have communication directly between the different sites, between the for example, 2 and R3, R3 and R4. Here we have some different type of point-to-multipoint technologies. For example, in one technology, maybe you don't want to have connectivity between the branches at all, and in some methods, we want to have connectivity between the router 2 and router 3 and router 4, but from router 1. This means that the traffic first should go to the router 1 and then to the router 3 because of some security features, some other features. But this is the E3 services. In this picture, you can see the summary of these three type of Metro Ethernet. The first type is E-line. As you can see, here we have only two building, for example, two router or two device of the customer, because maybe this is a switch. We are taking one E-line from the service provider, from the carrier Ethernet services, okay? The E-line is a point-to-point connection, point-to-point Ethernet WAN. And here we can see the E-LAN, or emulated Ethernet over the WAN ELAN. Okay, as you can see here, we have a LAN. This is like a switch. We have communication between all of the sites, and you know that here we have, for example, 5 building, 5 device, router or switch, and with ELAN all of them are connecting to each other, but only with one EVC. This is the multi-point EVC, and here we can see the E3. In E3 we are using the hub and spoke topology, or point to multi-point. Okay, all of these names are correct: point to multi-points, hub and spoke, and also the E3. Now let me to talk about the for example, one simple scenario about the routing in ELAN or maybe in E-line. This is our simple scenario. I'm going to show you what is the difference between the routing in E-line and also ELAN. You know that here we have one E-line cloud that this is configured before, and the configuration of the E-line or ELAN beyond the scope of CCNA. Look at here. Actually, now we have two EVC between router 1 and router 2. We should configure only the IP addressing, because I'm going to show you. Look at here. One EVC is established between the router 1 and router 2. Another EVC or Ethernet virtual circuit is established between the for example, router 1 and router 3. For this EVC, I'm going to use the tag 2, okay, the router 2, and then the other EVC should be established with tag 3, .1q tag 3. Okay, let me to configure it. The configuration is not important for you in this class. Only you should creating a sense for you for better understanding the E-line and also the E-LAN. First, E-line. Look at here. In the router 1, we need to configure the IP address. First, interface fast Ethernet 01, the LAN interface IP address 192.168.1.1.255. 255.255.0, and then no shutdown. After that, interface fast Ethernet 00. We should enable the interface with no shutdown. After that, we should configure two sub interface fast Ethernet 002 encapsulation.1q2. Okay, and then IP address is you have learned about the configuration of sub interface before in the inter-VLAN routing topics. Then IP address, here we need one range of IP address. You know that for each E-line we need one specific range. For example, here I'm going to use the 10.0.0/30. Okay, and after that, in the link between the for example, router 1 and the router 3 in this virtual circuit, I'm going to use the 10.0.0.4/30. Okay, let me to show you. IP address is 10.0.0.1, okay, 255.255.255.252, and then about the next interface fast Ethernet 003 encapsulation.1q3 IP address is the 10.0.0.5.255.255.255.252. That's it. This is the configuration of the router 1. Let me to configure the router 2. In router 2, we have two interface fast Ethernet 01. IP address of this interface is 192.168.2.1. Okay, the LAN interface 255.255.255.0, and then no shutdown. Also, interface fast Ethernet 00. IP address is 10.0.2.255.255.255.252. As you can see here, I didn't configure the sub interface here. maybe you want to have one E-line, direct E-line between router 2 and router 3. It is possible, but for our scenario, it is a good practice to have only 2 E-line between router 1 and router 2 and router 1 and router 3, because I'm going to show you the result of the E-line configuration about the routing. Okay, this is the R2 configuration, and then the router 3 conf interface facet